In topic 2 of chapter 5, we're going to take a closer look at exponents and the scientific notation. Again, as we use various rules, I will give you a little briefing on them. Now, we had mentioned the product rule earlier. This is the power rule. That is, when you're raising something in a parenthesis that has an exponent to a power, we don't add in this case, we multiply. So this is the power rule. The other one was the product rule. So we'll give you a few moments. So here we're going to multiply x to the 6th, x to the 4th, y to the 6th. Now remember, this exponent applies to the numerator and denominator. X to the 4th over y to the 6th. Now, again, they only want positive exponents. So this comes out as m to the negative 12. Remember, there's a 1 there, so we leave the 1 there, but we bring our base and exponent down to the denominator, and the sign of the exponent changes. Okay. Now, here a couple of things are going on, so we're going to do it carefully. Now remember, the 2 has an exponent of a 1 there. So 1 times 2 is 2, so this becomes 2 to the 2nd power, which is 4. X, 2 times 2 is 4. There's a 1 there, so this will be y to the 2nd, z to the 6th. Now here we're going to raise 3 to the 5th power, 3 to the 5th power, x to the 20th. Now this is going to be y to the negative 2 times 5 is negative 10 in the denominator. So we bring it up to the numerator and it becomes a positive 10. Now our book wants to raise 3 to the 5th power. So that would be 243. X to the 20th, y to the 10th. Okay, this one's a little tricky too, because there's a 1 by the 4, so this becomes 4 to the negative 3, which is going to go down in the denominator then as 4 to the 3rd, which happens to be 64. 4 to the 3rd power in the denominator. Now, x to the negative 5 times a negative 3 becomes x to the positive 15. Now, this is 3 times a negative 3 makes this a negative 9. So this will go down to the denominator as a positive 9. Now, I'm kind of skipping a step here where maybe you could put it up there and then later bring it down, but I think hopefully you're catching on. Now this is z to the 0 power, which is going to be a 1, and 1 to any power is 1, so that just goes away. Theoretically, it becomes 1 to the 3rd power in the denominator, but 1 to the 3rd power is 1 times 1 times 1, which is 1, and we don't write it. Now here we have a negative 2 to the negative 3 power. So this is going to become, keep in mind the negative 2 is part of the base here. This becomes negative 2 to the 12th power. And this is going to be y to the 12th power also. Now, they don't want it in the form of negative 2 to the 12th power. When we are multiplying a negative 2 by itself 12 times, that is an even number of times, the answer is going to be positive. And that happens to be 4,096 y to the 12th then. Okay, and there is no division bar here, by the way. This is one of the answers, and this equals this down below. Now, as we continue, they get a little more challenging. But again, as we multiply exponents, negative times negative will give you a positive. Negative times positive gives you a negative. So the same rules apply that we've mentioned earlier. So here we have a negative 3 times a negative 2. That's going to give us a to the 6th power. Negative 4 times negative 2 gives us b to the 8th power. And negative 9 times negative 2 gives you c to the 18th power. Now here we have a negative 4 to the 3rd power. You can think of it this way, negative 4 to the 3rd power. Now, when we have an odd exponent, odd number exponent, and we have a negative, then negative times negative times negative will give us a negative. And that's a 64. 4 to the 3rd power is 64. And then this x, 2 times 3 to the 6th power. Now, this is a little tricky too, because we have a negative 5 as an exponent. Now, there's two ways to do it. You could do it just like this, and in fact, let's just do it like this. And I'll show you the other way in a moment. So this is going to be n, multiply these to the negative 30. This is going to be 2 to the negative 5th. And this is going to be m to the positive 15. Now, we don't want negative exponents. So this will equal, and remember there's a 1 up there, but I'm going to move the 2 to the negative 5 up there. That'll be 2 to the 5th, and 2 to the 5th is 32. So I'm moving this 2 to the negative 5 up, it becomes 2 to the 5th up here, which is 32. I'm going to move I'm going to keep the m down there, m to the 15th. And now I move the n down, n to the 30th. And that's the answer. All right, that's a good way. Let's not confuse you with other things. Other things could be done here, but the answer comes out the same. Okay, now as we look at D, This 7 to the negative 2 comes down here as 7 to the second, 7 squared, which is 49. Now our y to the 10th is still up there. We're going to bring this negative 4 up, and this becomes then y to the 14th. And we're going to bring this x to the negative 2 down here. So we have x to the third already. Adding 2 more to the third gives us a 5th. And there's the answer to this one. Now, in doing letter E, we have a negative 2 to the negative 3 power. Let's just write that. Negative 2 to the negative 3. This is going to become x to the 0 is just a 1. 1 to the negative 3 would be 1 to the third down here, which is just the 1 that we don't have to write. And this is going to be y to the negative 6. But we only want positive exponents. So, to bring both of these down, we need to leave something up in the numerator. So we leave a 1 there. And now this is going to be a negative 2 as our base to the third power, which is a negative 8. And eventually we're going to put our negative sign over there. So let me do that now. There we go. But it went down there as a negative 8, but we usually put the negative out by the division bar. And then this is just y. As we move this to the denominator, y to the 6th. Now I have students who have, put this as the answer, negative 8y to the 6th. And that's not the answer. You can't put this in the numerator. You have to put the 1 in the numerator and this in the denominator. Otherwise, it's incorrect. Okay, so we can simplify this a little bit. We have x to the third. And then now this is going to be x to the third times the negative 3. So this will be x to the negative 9. I'm going to simplify this a little bit. This is going to be b. There's a 1 there to the negative 3. And this will be y to the negative 3. If I were doing this, I would, kind of take shortcuts, but we want to show you the pattern of what's going on. Now, when we combine these two, we're going to end up with x to the negative 6. Again, that's going to go down to the denominator as x to the 6th. And where did it come from again? 3 minus 9 is negative 6. To make it positive, we move it across the division bar, and it becomes a positive exponent. And these others just go down. B to the third, y to the third. So again, not too difficult, but you need to follow the rules. Okay. Now, one of the things we may have mentioned before, and I'll get to that shortly, but let's just do this one here. This is going to be 2 over the z to the negative 3 is going to come down. The y is down already. So now we've simplified this. And a rule that we have is when we have a negative exponent out there, we can just flip this over. This becomes a positive one. Or we can treat it this way too. So let's just leave it this way. So this is going to become 7 to the negative 1 as we multiply it by that, which I'm now going to put in the denominator here as a 7. So 7 to the first multiplied by negative 1 becomes 7 to the negative 1, and I've moved it down 7 to the first. Alright, this is going to be y. Negative 5 times negative 1 is to the 5th. And a negative 2 times a negative 1 makes this a positive z to the 2nd down there now. Okay. Now we kind of simplify. Our fraction is going to be 2 over 7. See, my pencil got thinner. This is y to the 1. I'm going to subtract it from the 5 up there, so I get y to the 4th up there. Subtracting that 1 from the 5. And then I just get, in the bottom here, z, we have it to the 3rd and to the 2nd, so that'll be z to the 5th. And that's my answer for letter G. Okay, and I think I like my thicker pen, so let's go back to that. Now there's a 1 there, so this is going to become 3 to the negative 3, and that in our denominator becomes, let me just write it out here, 3 to the 3rd, which I'll expand that later. This is going to be x to the 4th times the negative 3 gives me, in the denominator, x to the 12th. Remember, up in the numerator it would have been positive, negative. We had to bring it down to make it positive. And this is going to be y to the 6th. In the numerator it would have been y to the negative 6. So now the 2 is just there, and we have x to the 8th, y to the 3rd. Okay. Now we can do some simplifying. So 2 is just going to be 2. 3 to the 3rd is 27. And I'm going to subtract 8 from this 12, and I get x to the 4th. And I'm going to subtract 3 from this 6, and I get y to the 3rd. And then that's my final answer. Now, in these last few, we're going to multiply this by this, and we get this. And we're going to add our exponents. So a negative 9 and a 7 gives me a negative 2. Now, you might say, well, that's in scientific notation. And the answer is no, because this is not a number between 1 and 10. So what do is I move it over 1 decimal. This becomes 2.94. And since I moved it over 1 to the left, I have to add 1 here. So this now becomes times 10 to the negative 1. I had to add 1 if I move it to the left. Now for this one, remember there's a 1 there. It'll be 4 to the 1st power raised to the 5th. So we multiply. This becomes 4 to the 5th power times negative 6 times 5 is a negative 30. So when I raise 4 to the 5th power, I get this. But this is not in scientific notation. I have to move the decimal place over 3 places. This is now a number between 1 and 10. Now, since I moved it over 3, I have to add 3 here, and that gives me a negative 27. Now, for this one, when I do my division, 3 goes into there 0.4 times, and I bring this up, and I have now, it was negative 4 in the denominator, now it becomes a positive 4. 8 times 8 plus 4 now is 12. Again, this is not in scientific notation. I have to put this as a number between 1 and 10, so I move it one place now to the right, and it becomes 4 times 10. Now, since I'm moving this to the right, I'm making a smaller number bigger, in a sense. I have to subtract 1. This is a negative direction when I move it this way. So this becomes 11. Now this is in scientific notation. And that winds up this lesson.